Welcome to the session, last session of the day, where I will tune a single query. I'm Milos Radivojevic. I'm head of SQL Database Engineering at Entain. This is the largest online betting and gaming company. And I used to play with large tables there and query tuning and so on. I'm used to speak at conferences. I'm co-author of 3 books. My LinkedIn handle, if you have questions or if you want demo or code from this session, I will send you when you add me on LinkedIn. So session feedback, please scan this for later. Do not deliver feedback right now, just wait for the session. But I'm not sure that I will show the slides after that. Please do session feedback. That will help for organizers, that will help speakers and so on. Okay. So let me introduce my database. In this session, I will tune a single query all the time. Just very small, straightforward, simple query. And I will tune this query about 50 minutes, and I promise it won't be boring. My database has only 2 tables. Database has a size 58 gig. It's SQL Server 2022, the latest intelligent features, everything is there. And it will be used in compatibility level 140. You will see later why. That means SQL Server 2022 will act as SQL Server 2017. And I have a 64 gig memory on this laptop. And as I said in my previous session, 64 kilo too. My database contains only 2 tables. Orders table has 100 million rows. Order details has 335 million rows. I do not have outliers. I know about indexes. I have indexed everything. So I have a cluster index. I have non-cluster index on order ID for columns where I plan to join. I know everything about indexes, so I'm fine with that. And I do not have outliers. That means I do not have an order where I have million order items. I do not have customer having million orders. Everything is pretty uniformly distributed. And this is my query. Select from table from orders, join order details, where customer ID equals something, and this query returns 248 rows out of 100 millions and 335 millions. And in cold cache, it takes 11 seconds. How long should this query take? What is expectation? If I have indexes, if I have everything, if I don't have here a data type conversion because customer ID is also integer, so everything is fine, query returns just few rows, what is the expectation? To be like this. Regardless of table size, if I have everything, if query is selective enough, it should be like this. But it's not, otherwise we will not have this session. Okay, let's jump now. That's all from my slides. Let's tune. Good, so here is the query. I will execute this query. It's cold cache. Okay, it's not cold cache. I executed before the session, so it doesn't take 11 seconds, but 2 seconds. And you can see here that this query, come on, use 25 seconds of CPU time and 3 seconds. It takes about 3 seconds. And when I look at the execution plan, you see here that SQL Server has choose hash join. And then I have this, in this plan, I have a cluster index scan. And my table is 335 million rows. That means SQL Server scans large table. So good. This is a starting point. It's my query. And you have a first takeaway already from this session. This is SQL Server 2022. Okay, it acts as SQL Server 2017. But you can still have very simple query, which doesn't perform well. With all this intelligent query processing, great things, you are still in charge of query tuning. It's a very simple thing. You still need to tune your queries, regardless of what they say. Vendors or whoever, you need to tune your queries. It's up to you. Okay, when we have A join B, join is a logical operation. When you write the join, you do not tell SQL Server how to do this. You tell SQL Server, I want to have details from orders table and from order details for this particular customer. And SQL Server needs to implement this join with one of 4 operators. Nested loops join, which is used when you have indexes on these own columns, and when you don't have a lot of rows. When you have a few rows compared to the table size, nested loop join is a good choice. When you don't have indexes, or when you operate with a lot of rows, hash join is choice for SQL Server Optimizer. When data is sorted on the same with the same columns, you can have merge join when SQL Server can stream data. When you see it's sorted per customer ID, when you see 5, then when you see 6, you know 5 will not come anymore, and you can send results for 5 if it's sorted on both sides. It's a very rare case. And the fourth join is adaptive join. If you have SQL Server 2017 at least, and your query running batch mode, you might have adaptive join, which is a combination of nested loop and hash join. Generally, SQL Server usually choose between nested loop and hash join. And what we told for nested loop, I need to have indexes, and I need to have few rows compared to the table size. And I have this here. Few rows compared to table size, 248 few rows, and I have indexes. And SQL Server did not choose nested loop. So the second takeaway, you can tune your queries better if you know your workload. It's fascinating sometimes how many developers don't know about the tables. I used to ask developer, what is the table size in production of the query that you just right now check in the code? Many of them don't know. Some of them even don't care. So you cannot tune your queries just, there is a rule how to tune queries. You need to know your workload. In this case, I need to estimate also for other customer IDs, will this query ever return more than a few thousand rows? If I know this, then I can have expectations, okay, I would like to see here nested loop join. If I know that this query will not return more than a few thousand rows ever, then I can tell SQL Server, okay, I was disappointed. I have expected the SQL Server will choose this, but he didn't. I can tell him, okay, you have to choose nested loop join. And what will happen now? So out of this thing, I forget to comment this thing here. When we have set statistics IO and set statistics time in a query in a Management Studio, we force Management Studio to show us how many pages had SQL Server to load into memory in order to generate results for this query, and also how this took and how many CPU. We see that's 25 seconds of CPU and almost 3 seconds it took this query, and about 5 million logical reads. That means 5 million pages had SQL Server to load into memory to generate results for this query. And now I will tune this query. I will put the just loop here. With loop, we do not let SQL Server choice. Now, okay, you will implement this logical join with nested loop join. So, from 5 million to, I don't know, a few thousand, query runs quickly. And when can you stop query tuning? I mean, you can do whatever you want. It's your query. You can do this. Can I stop here? What's the problem? It was 11 seconds, then it was 2 seconds. It was terrible. Now it's great. Why not? Sorry? Yeah, I used the hint. That's true, but I wanted to use hint. I was disappointed. I'm sure that this hint is okay. And the fact that you can read off, you should not use hint because you then do not let optimizer. I don't want to let optimizer to make decision because I was disappointed. I want to take responsibility. I use a hint, and it's fine. With my hint, it works. With Microsoft hint, doesn't work. Okay, the question is, may I stop now? Whenever you do performance troubleshooting, if you don't know about execution plans, go to sessions from Hugo Cornelish or his seminars on YouTube or his homepage. You will find great sessions and great workshops about execution plans. But you don't need to know everything here. Whenever you do troubleshooting, do one thing all the time, especially when you are proud, as I'm right now, with my query tuning. Just go to very left operator and mouse over it. And this mouse over, you will see some interesting thing here. What is the most interesting thing on this page or this mouse overing thing? We have one information which is a bit, can look as a concern. Yep. Memory grant. Memory grant, 10 gig. 10 gig of memory grant. 10 SQL Server, this query request from SQL Server, 10 gig. And we have to be fair. Few milliseconds, 10 milliseconds later, this will be given back to the system. So if I would occasionally execute this query and I have enough memory, it's not a big deal. But when could be a big deal? When we run this query in parallel. The second thing, that's the reason why you need to know your workload. I can tune a query, but it's not the same if this query is executed a few times per day or I know, with 1,000 sessions at a time. And now I will simulate this with 200 sessions by using famous tools, SQL Query Stress. If somebody doesn't know, just Google SQL Query Stress. I think now it's Eric Jensen made this tool. It's a tool originally from Other Mechanic. It's not sophisticated, but it's good, especially for demos on conferences. And I will simulate here. I will execute this query 200 times with 200 parallel sessions, 50 times, the query that I tuned for. But before that, I will just show you two diagnostic queries. First one, just list processes and sessions that wait for some resources. And the second list also request what memory is requested from SQL Server and what is given to this query. And as you can see, this is my laptop. Nothing here happens except my session, so it's boring. But now I will start this. I will just copy paste the thing that I have tuned, that I was proud about. And I will run this, as I said, 200 sessions, 50 times. It's, I don't know, 10,000 sessions. And let's start this. And let's go here to this workload. And what we can see here is something which is not so good. We see resource semaphore waits, and we see reason why. So each query requests 10 gig. I have a 64 here, so I have enough memory in my laptop to serve 3 requests. All the other need to wait. And in this case, it's not a big deal because it's my queries only. In production system, everyone compete for memory. For CPU, you will make problem with this. And this query bring my server under pressure, memory pressure. Also, I was so proud to fix this issue. I have an inner loop join, did the job, but now it seems we are still in trouble. So I will repeat this again so that you see. So when I execute this without concurrency, it works like this. When I start this, you can see you don't need some metrics. You see optically that's not. It's still okay. It's not so bad as it was before, but it's still, you know, it's almost 1 second I need to wait here. So memory pressure. So it's time for second decision. What I did so far, I overwrote one decision from SQL Server Optimizer. Instead of hash join, I use a nested loop join. Now I have a problem with memory. And again, I need to know my workload. So why SQL Server use this needs memory here? Which operator here needs memory? Sort operator, sort operator. And what is the, here, there are stupid things. When you see all the time, you can see order by. Order by is so many times used without any reason. If you have a top, order by is a part of the business logic. If you don't have a top, order by is not necessary there. But people like order by. They want to sort this before to send to application server, which is cheap, where you can sort, I know, 10, 15 rows, whatever you want, but people want to sort to the database, right? And this thing is responsible for this memory grant. And I know that this query, so why is this query, why SQL Server needs, why this query requests 11 gig or 10 gig from SQL Server? Come on, please, please. Because it estimates that this thing is about 9 gig. I need to sort 9 gigabytes of data. And then, okay, give me. In reality, it needs to sort 200 rows. You need the 1 megabyte, it's enough for that, but SQL Server doesn't follow actual number of rows, it follows estimated number of rows, and basically you have here problem. But I know, SQL Server doesn't know. I know that we don't need more than a few thousand rows. I know that this query doesn't need too much memory, and the second decision is I will limit this memory. I will tell SQL Server, do not use more than X. I can go with a hint, say, okay, option. I need Copilot for that. Max, grant, %. And unfortunately, I cannot tell SQL Server to, cannot give absolute max. Absolute value, but I can give relative value. So do not use more than 0.05% given to SQL Server for this query. I still have the same plan, but now there is no this triangle. So less than 10 meg, 9 meg, from 10 gigabytes to 9 megabytes. It's nice to have this thing here. So I fixed the issue. I can go now with this and try the same. I won't have any more this issue, but of course we can hit something else. Here, all looks fine. I can have some other, in some cases you can have latch contention or something like that. Here I even have a solution for that, but in this case we solve the problem by eliminating memory, by limiting memory to SQL Server, to this particular query. So I took 2 decisions instead of query optimizer. One, to choose nested loop join instead of this hash join, and second, to limit the memory. And if you want to be perfectionist, when you look at this plan, what is here not necessary? What is not needed here? Query return few rows. Parallelism. So I don't need parallel plans. I don't need multi-threadings. It's basically a straightforward thing. I just need, indexing, KLOOKUP. It's really a simple query. And how to eliminate parallelism? We can put max.1. And now I have third thing, max.1. And now this thing looks good. This is what I have expected. And even SQL Server says it's again wasting of memory, but it's not a big deal. So basically it use less than 1 meg. I give them 5 meg. I can live with this. It's not a big deal. So we end up with a great plan. This is what I had expected at the beginning without tuning. The query return few rows, nested loop. This is what I wanted. I didn't get it, and I have to fight for that. So I took responsibility for that because I knew my workload. If I don't know my workload, if this thing it's not applicable for all my queries, then it's my fault. It's not Microsoft's fault. I cannot claim anymore. It's my responsibility. It's my decision. So this first approach is if you know which plan to have, you can make this decision. You can use hints, and you can override decisions to optimizer to get plan what you want, what you have expected from optimizer. This is the first approach. You can have this approach if you know exactly that this plan will be good now, will be good in the future for all queries all the time. You are not in a situation to have this, to be confident that this will be always the case, but if you have, in this case I am, there are cases where I know. In betting you have always an ID, and I know that for this ID I will never have more than, 10,000 items, whatever that means. And it's like, I need to know my business. If you don't know if everything is possible, of course, you cannot optimize when somebody says, yeah, but we have to be flexible, everything is possible. Okay, good, then we will not optimize. So this is the first approach. Any questions? So we make decisions instead of an optimizer. The second approach is, let's help optimizer to make better estimation. What we did not touch here, look at this, this plan is good. But SQL Server still thinks it will be 41 million rows. We did not affect this at all. We just make the overall decisions, but he's still, okay, I think it will be 40 million rows there. The second approach is, let's try to trick optimizer and to help him to make better estimation. And this is the second approach. This is a common approach when you have complex queries. I don't have complex query. I have a query which is very simple, but unfortunately I have a problem with performance. But for complex queries, A join B, join C, join D, it's so many combinations for Query Optimizer, and it might help if you split this query in several queries. And this is what I will do here. In order to avoid wasting time, I will just double click. But I waste time to find them, it's the same. Okay, so here is my query. So what I did, instead of select, okay, let's compare everything here. So in first select, I put in the table variable. When you look at this code, I look as a moron to do this, because from a simple query, I make something which looks ugly. I extract select from orders, where customer ID, and put it in the table variable, and then join table variable with the rest of the things, and make it complicated. But when the code looks moronic, it might work. And let's see if it works now. Copy paste here. Just please write moronic code. Moronic code performs well. So here's my plan. Serial, I have a nested loop, and I don't have a memory grant warnings. All fine. When I use table variable, whenever you hear about table variable, do not use them. They are bad. Don't touch table variables. But look at this. They are good. This is a proof. So what I did here and why I did here. It might be, I mean, I'm not moron. Maybe I am, but this is not the proof that I'm moron. So this is a original query in a single table. And here we have a problem. So for this customer, I have 245 orders. SQL Server thinks this customer has 32,000 orders. And this is where the problem begins. This is not a big deal in a single table. But when we join this table, SQL Server have huge overestimation here, about 130 times more. And then I have another overestimation when I join with another table. What I did here, I send this in a table variable. And then if I send this 32,000 estimation in the table variable, what is the most important property of a table variable? Sorry? Estimation of 100 rows, no. I mean, this is a multi-statement table value function. One, estimation. The most important property is cardinality. There are other things, they don't have statistics, whatever, but the most important property is SQL Server thinks there will be one row there. You can have 10 million rows until SQL Server 2019 and compat level 150. SQL Server thinks about 20 years, it will be one row. And what I did now, instead of 32,000, I get one. And what happens here when I run this query? I had a huge overestimation. And here, in the original query, I had a 32,000. Now I have one. I'm even more wrong than this one, but I'm wrong in another direction. I intentionally underestimate things there. And then when two wrongs meet each other, they can make it almost right. So underestimation, and this is what happens here. I have overestimation in an order details table. And look at this. This is excellent estimation for this table size. It's 3-4 times more. So I have 284. SQL Server thinks it's 1,200. And then SQL Server doesn't need my help to choose operator. Of course, it will choose nested loop. Of course, it won't give a lot of memory to this query. And of course, it won't go parallel because it expects 1,200. I help them. It's my contribution here. I help SQL Server to make this. And this is the reason why. So you can use or misuse table variable to compensate overestimation in queries. Sometimes you do this intentionally, as I did in this case. Sometimes you are just lucky. You have a select complex query in your system, and you have overestimation, but luckily you have table variables, and they do something each other, and then everything is fine. And then you see intelligent query processing in SQL Server 2019. There is a feature called table variable defer compilation. And now I will make this a bit more complicated because I do not have third table. I will just introduce third table here. And I will explain everything, just do not. So go 140, and I have here third table. And I use this approach with table variable. But now I won't get excellent plan because I have 2 overestimations and 1 underestimation. But let's assume that I'm fine with this. I will execute this query. And it's fast. So the most important thing, it is fast. And it goes parallel, or it even doesn't go parallel. So it's excellent. You see there is a discrepancy because I compensate 1 overestimation, but I have another one. But that was not bad enough that SQL Server even goes parallel. So I'm fine with this. It works. I fix it. I forgot about this. I go to fix something else. And then we're out of mainstream support. This is the most important reason why people make upgrade to SQL Server. Out of mainstream support, and there is intelligent query processing. When you make upgrade, why should I use? I should use these features. And now I will go back to 150, go to 150 compat level. This is SQL Server 2019. And I will run this query. And as you might guess, it won't work. I fix it, I did it, and now it doesn't work. And what happens here? Hash join, cluster index scan. Why? Because after 20 years, Microsoft has fixed this problem with table variable. There was 1, and we had to live 20 years with 1, and now they change it. Now they say, oh, this was wrong, and this is true. It's a bit now, I mean, it's strange. That was almost always wrong. Only if you have exactly 1 row, it was right. That means we had to live with this wrong, and I'm fine with wrong now. And it's 20 years. Now you make it right, and now I'm in problem. Now it's always right, and I should not complain because table variables show exact number of rows, and I should be happy for that. But now when you look at this, what this thing does, I use or misuse table variable property 1 to fix the problem. What they did, they fix it now, and instead of 1, I will get here 240 something, 245. And this is on the very right side on my execution plan. That means all execution estimations are multiplied with 245 on the left side. That's the reason why I have added third column. If third table, if I would go with my initial query, it will just go parallel, nothing else. Now I need a third. So it's question of time. So 245. Imagine that you have a query which work well. And of course you have queries which work well. Otherwise, you will fix them. I cannot wait for Microsoft to fix table cardinality. Of course, I fix my queries. My queries 5 milliseconds. And then you multiply this with, I know, thousands or 10,000. Of course, you will be in trouble with that. The good thing with table variable defer compilation and all features from SQL Server Intelligent Query Processing package is that you can suspend them at the statement level. If you see something, I mean, you can detect this by intensive testing, but as we know, we don't have a production-like system really before we go to prod. Usually we see such problems in production, but it's a good thing. You can fix it quickly. You just need to put a hint. And with this hint, you can tell SQL Server to interpret table variable. So I need to find the hint. Yeah. Disable defer compilation TV. I mean, it's not consistent. And there's the other things. And now I will go here and I will get the same performance as I had in under 140. So, I mean, it's not the same, sorry. So you see now it's parallel. It's not exactly the same. You change compat level. It's a different thing. There are many rules that have been changed, but the most important thing, behavior of table variable is the same. So basically, I will now go here and see again what I wanted to see. I want to see 1 here.
Okay, so even if you're on compat level 140, or even if you have this hint, you can still get the correct estimate, because if that join happened to be recompiled because of that statistics update, it will use the actual cardinality of the table variable. Just saying.
Just if it's, or you can put option recompile, you will get it.
Yeah, that's also true.
Option recompile will make from 1, it will make a real actual number of rows. But this is very expensive, and we don't use this in such queries. Now it's option recompile is used only for the first execution in 150, and then we're in trouble here. Of course, we can have, there is no guarantee the table variable will be 1, but in most cases it is. Good? Somehow. Okay, any other questions? Online questions? No. Excellent. Okay, good. So this is the second approach. So in the first approach, I took decisions instead of optimizer. In the second approach, I do. So I didn't do this here. I didn't use temporary table. Why? Why I use table variable? Because I needed 1. So temporary table won't have 1. Temporary table will get similar to table variable right now. Will get exact. I will get 245. It's not enough. There are other things you can do to fix this. And of course, all these things are workarounds. Both the first part, where I just took decisions instead of an optimizer, it's a workaround. This thing is again a workaround. In the first case, I took responsibility. I need to know my workload. Now I help a bit optimize. This is a defensive thing. This is a less my responsibility. I help the optimizer to make better decisions, but basically I did not put the loop. I did not put the limit of memory. By the way, what will happen if SQL Server really needs more memory than I give to this query? Yep, spill to 10 dB. So it's not so dangerous. If if you're wrong with assumption, of course you will get penalties for that, but it won't fail. Like when you put an index hint with index name, query will fail. SQL Server can still make another plan, but it doesn't. This query will fail, so it's not danger that, okay, I give to this query, I know, 0.05, it needs more, it will fail because it cannot get more. It will spill to 10 dB. So this approach with table variable, with tricksing is common when you have complex queries, and you have to be careful with table variable in SQL Server 2019. I'm fine with table variable defer compilation for the future code. It's a great thing. Now we can choose between 2 behaviors. If I want to have 1, just to put a hint, and I'm fine. Put a hint within this query, and you can have the old behavior. If you don't put a hint, you have a new behavior. For the new code, it's good. In my legacy code, I had to put option recompile or different tricks to make SQL Server to have better estimation for table variable. So it's a great thing for future code, but for a legacy code, sometimes you're just lucky that your query performs well, and then this is a huge change. When they change from 1, to 10,000, they multiply 10,000 times all estimations, and this can go wrong for your queries. Just a question of time. Okay, both of these are workarounds. And what is the problem actually with this query? Why SQL Server thinks it will be 32,000 rows here? Why? Normally, this one. Come on. Where this thing is coming from? Statistic. So there is statistic and there is statistics object, most probably with the same name as the index, ix1. And let's go to see statistics object. dbcc show stats. Statistics. So ix1 orders. What we can see here, this is a stats header telling that, that this statistic update is done by using 441,000 rows sample out of 100 million. This 0.4%. And this is some average, meaning we have 1.29 versus 12,000 or 12,000 orders per customer in average. This is what SQL Server calculates in the statistics. And this is statistically significant values here. And in these values, we can find our customer ID, 9 for this one. And you see here equal rows that SQL Server, according to statistics, expect 32,000 rows. So and this is, you can see, wrong, very wrong. And all of them are actually overestimated. You see 10,000, 11,000. So the reason why is that for large tables, SQL Server updates statistics with default sample rate. Updating statistic will happen when? Until 2014, it will happen when 20% of rows have been changed. Actually, when 20% changes, if you have 100 million rows, you need 20 million changes in order to get stats update. After 2014, they changed the formula, and there is a square root of 1,000 multiplied table cardinality, which means if you have a billion rows, after million changes. The funny thing is, not after million rows have been changed, but million changes. If you change one row million times, you will get stats update. It's stupid, but it will work. And if you don't change anything, you begin to run, you change something, you roll back to run, you did not touch the table, so you will get stats update. Because this thing will frequently come when you have, odds like betting company or stock price. When you update price, you update a single row 1,000 times. And 1,000 rows, 1,000 times, a million changes. Basically, you update, in reality, you updated 1,000 rows out of 1 billion, and you get stats update. And you will get more or less the same histogram, everything, the same plans. You do it for nothing. Default sample rate will go down when you have large tables. The small table SQL Server will have the entire table. For moderate tables, it will go to 20%, 30%, and for large tables, it goes less than 1%. And then what happens? They do not, here we have 0.4, or let's say 0.1, every 1,000th row. They do not read every 1,000th row. If you need to read every 1,000th rows, you need to read everything, all pages, and then to find, there are 1,000 rows. They'll just grab pages, and then this page, the interpretation, it's my guess, I don't have a proof of that, it's not documented, but it looks like this when you look at numbers. They expected in pages that they did not read, more or less the same situation, which is stupid when you have, order date or ID ascending keys. I have an order date here, and in this page, I have 1,000 orders for, 1st April 2020. And then 1st April 20, you should not assume that in all the pages that you did not read, it's again 1st April 2020. That's the reason why it's always overestimated. And if you have large tables, you can have, terabytes or 10 billions. You can have a huge overestimation, which is a great potential for many performance problems. It's just up to you or your workload, or join this. It's not a big deal if this table is a log table and you do not have joins between this table and other tables. It's acceptable, but as you have joins, as in our case, this can be a huge problem. So this is the root cause for the problem. And when something is root cause for the problem, we need to eliminate root cause. And we need to update stats with more sample rate. And I will update this statistic with 50% and 20%. Why 50% and 20%? Because I play with this percent, because I want to get excellent estimation. But generally, it's enough for large tables to have something like 10%, 5%. Don't go under 1%. I have a table with now 17 terabytes, single table 17 terabytes. And I have update stats with 5%. And this update stats take 4 hours and reserve 200 gigabytes of memory. So basically, 200 gigs, 4 hours, and more or less, you get the same execution plan. Thanks. for same execution plan, I mean, it doesn't make sense to update statistic if you will get the same execution plan. And here I have just picked these numbers, and this is my original initial query, and I don't need here to tune anything. This is what I have expected. Small number of rows, nested loop, serial, everything without my intervention, without my table variables, without all these things. I don't need to touch it. You have to do this. And in addition to my workarounds, what is the advantage of this thing that I did right now? That's the reason why 220, I just pick it to have a great estimation. What is the advantage of this approach? I fixed only my query, single. If I have several such queries, I have to open several queries and fix all of them. Here, when you eliminate the root cause, all queries where these tables are involved, that will be beneficial for them, because you will fix something that you don't know that exists. In some corner cases, I have to tell this, in some corner cases, fixing an estimation problem might be a problem, because you have several problems there, like in this with table variable, and if you fix one of the estimation, you can damage something. This is a corner case, really. It's a good, when you see something like this is an excellent information. So SQL Server think it will be 223, you have 248, and all decisions made by Optimizer are excellent here. Optimizer does a great job. But if we have discrepancy in estimation and actual number of rows, then you might expect different problems here. So the solution for this, general solution for such dealing with large tables and with such queries, do not let SQL Server to make automatic update for statistic with default sample rate. Choose higher sample rate. And I have here fixed the problem. And what happens now? We just run and run. We have no more orders. Of course, people want to have business. We make more orders. And then what happens? It happens automatically starts update. What SQL Server does when we automatically starts update? SQL Server does something like this. And you see that I cannot talk during this update starts because it's done like this. That's the reason why Microsoft choose to have inaccurate starts, but basically do not use a lot of resources from your system. It's done. What will happen now? So I fix it. Microsoft bring it again. If you work with a lot of developers, you know what I'm talking about. We fix the problem. They say we will commit the change then later. They do not commit change. They come next rollout and you fix it. You overwrite my fix. So again, we are in trouble. So there is a solution for that. So whenever when you have a large table, just use persist sample %. This is an option available from SQL Server 2016 Service Pack 1. Then SQL Server will next time, when automatically starts, when auto starts update happens, it will respect your sample rate that you define during this with this persist sample rate. SQL Server will respect this, and it won't go with default. Otherwise, you need to fix it. You just wait. Okay, it's again a problem. I update starts. It's stupid. So basically, you will do this with sample rate. So there is no free lunch. If you do this, you will increase CPU and I/O and memory from your system. As I said, I have a query update starts that will take 4 hours and block 200 gig. And the thing with large tables is, I had this in my session today about large tables. Large tables should not be treated as other tables. You have to have special treatment for them, and you should not apply all these maintenance things you apply for everything else, for all the other tables. So, including update starts. When I see these 4 hours, 200 gig, I get the same plan. Okay, am I moron? Why I use all these resources to update stats? Because stats should be updated. What if I do not update stats? And you can use no recompute part. And that means you will take over about statistic maintenance for this particular statistic. I don't want that this thing is updated every time. I don't want to update this every day, few times per day. I want to save a bit resources, and it makes sense to update stats only then if you have expectations about the new plans. Here, I don't have any expectation. I want this thing to be like this forever. And update stats won't bring me anything here. For some queries it will bring, but here basically every day update stats will not bring me a lot of things, and therefore I will update stats once per week or even once per month. It's up to me. But the thing is, you are now responsible. You should not forget about this. You should never. I had a question in my previous session. We just turn off create and auto update stats. Never ever. You should do this. You should take out of this automatism some statistics, but it's a good thing for almost all statistics objects. Maybe few of them you should take over. For few of them, just pull out, and you're responsible for them. I don't know, once per week, as we did, I don't know, Monday, something, and then in the night, and you update this. And you watch, or you update stats and look at the histogram. If you get more or less the same histogram, why you do these updates? Generally, it's a good thing to update stats, but if you have, I don't know, big imports, if your data significantly change, data distribution, makes sense then to respect this, and SQL Server Optimizer maybe should choose something else. But in many cases, for large tables, in OLTP, I don't want to see anything else but index SQL lookup. I don't want to see hash. If I see hash, I'm dead. So therefore, I want stability, and if you want stability, don't change things which you don't need to change, or which change is expensive. So therefore, you need to choose higher sample rate. You have to put persist hint to preserve this sample rate. And if this is expensive or too expensive, then you can use no recompute to update this whenever you think it should be updated, not when. This is especially for systems that I described, when you have so many updates in a single row. I don't know, stock price, odds, or such things, where you have in large table to have several updates of stats per day. This is a huge thing. Okay, then I'm done. I have another slide just to summarize this, but this is nothing else than from current slide. Just even with the latest SQL Server versions, simple queries can still be very slow. You are in charge in query tuning. Regardless what Microsoft said, regardless what any other vendor said, you are in charge. And it will be. You will have also, I have even single query select from one table where without join, it's very slow. In 2022. When you know which execution plan to choose, you can use hints. I want to have this plan, but you have to be absolutely sure I want to have this plan. Just do hint, this, that hint. There are so many hints. It's a great thing to have them. Or you can trick optimizer to help him a bit to make better decisions. But whenever you tune query, just look at the execution plan. The funny thing is, we look at the execution plan when query is slow. But when I tune the query and it was fast, nobody looks, oh, it's good. Look at the details. Always look on the bright side. Always look on the very left operator to see memory grant. Memory grant is a hidden performance killer. And of course, all these things are mitigations. You need to find the root cause. It's a great thing to have a Saturday afternoon. I will choose always a workaround. I don't want to search for root cause. And but then after that, when workaround did the job, then take time and then search for root cause, and this root cause can bring additional things for you and make a proper solution. Any questions? Yep.
Hi, sorry. I believe you mentioned the resource, a YouTube channel about explain plans right at the very beginning.
Hugo Cornelish, this is the name of the...
That's the one, okay. I didn't get it. Okay.
Yeah, Hugo. So very, very known speaker, great dresser, the best dresser for execution plans. There is a Grant Ritchie book, I think, also about this, or Erland, but Hugo Cornelish is my choice, if you ask me.
I hadn't heard the name.
Sorry for all the others. You can do the same now. Thank you very much.
So SQL Server PASS.com, that's what you go to find Hugo's blog, and he has a he has some sort of execution plan PDA. And that's also going to Fischer's book, but I think Hugo's goes a bit higher level.
Yeah, but there is also a basic things how to start with execution plans and all those things. Absolutely great resource.
Yeah. And also, I hope you will know this, but in SQL 2022, and well, they already started 19, but they will fix the memory grant dynamically because, oh, wait a minute, this was way too much, and they will adjust it and persist it.
Yeah, thanks for that. So the reason why I used 2017, I had two reasons. One was that I wanted to play with table variable. The second is memory grant is somehow fixed. It's again, there are corner cases there, but memory grant is fixed in 2019 already. We have a batch mode and row mode. So when you run a query and SQL Server C, you did not use less than 50. The query used less than 50% of memory. Memory will be recalculated. It won't be recompiled the entire plan. They will just stamp the last thing, the memory which is used, and you will get exactly the same amount of memory that has been used for the last execution. And that was good for most. If you have a clear overestimation or clear underestimation, it's a great thing. But in 2022, as Aaron said, they changed. They did it a bit sophisticated. They did not get what you have the last, because when you sometimes need 1,000, sometimes one, what will be the next? I don't know. They do some math, and you will get some kind of memory upgrade, updated memory, which is definitely better than initial one. So you don't need to touch the query to fix memory grant. In my particular case, when I have a clear overestimation, it's enough to run this 3 times, and SQL Server would fix this memory in my case. So I don't need to play with this, but I didn't have time to demonstrate, and thank you for this, because I just intentionally remove memory grant from the story.
And we should say that this is also an Enterprise Edition only feature.
Yeah, Enterprise Edition feature, great. Batch mode and all these features that bring features without touching the code as mostly Enterprise features. Features that can break your code as table variable defer compilation are available in Standard Edition also. Okay, thank you very much, and enjoy the rest of the conference.